So number 18 is right up here, and it says we have a rectangular swimming pool that is 6 feet deep. One side of the pool is 2.5 times longer than the other. The amount of water needed to fill the swimming pool is 2,160 cubic feet. Find the dimensions of the pool. Wow, that sounds like a lot of junk, doesn't it? So what you do first is make yourself a little drawing. That would be nicer, right? If we could just swim in it. Alrighty, so it is 6 feet deep. Well, that's nice. They gave us one of the dimensions here, 6 feet deep. One side of the pool is 2.5 times longer than the other, but when I read the rest of this, they didn't tell me what the other side was. So I realized I'm going to have to use an X, and 2.5 times longer would be 2.5x. And then they start talking about filling this thing up. Well, that's volume. Volume of a box is length times width times height. So if that volume is 2,160, we're going to have to take this times this times this to get it. Bless you. So if you don't want to have to do any math in your noggin and transfer that 2.5 into 5 halves and multiply it by 6 to get the 15, you wouldn't have to. You could just plug it into your calculator and get the 15. And then we solve it like we did yesterday. So we're going to divide both sides by 15. And hopefully that works out to something nice. Oops, divided by. There we go. Oh, look at that. That's a really nice number. Because that's a perfect square. So if we took the square root of both sides, we would get a plus or minus 12. But here's where we use our noggin and say, this is a word problem. You can't have a pool that's a negative 12 feet across. So this would be 12 feet. And they wanted all the dimensions, not just the one. So then we have to take 12 times 2.5 to get the other one. And again, if you don't want to do the math in your noggin, you don't have to. That's 30. And then they already gave us the 6 feet. So those would be the dimensions. So I guess the key to this one would be remembering that volume of a box, volume of a pool, length times width times height. That's how we get it. Number 22 was the other one on your list. This one is an FAQ, but you know what? I'll just go ahead and do it because it leads in really well to what we're going to do today. All right. These were like the last ones that we did in class, where they've got this all set up for us. So what we have to do is recognize, hey, this is a perfect square on the front and the back, and so is that. So I don't want to start moving stuff around. I want to factor this into a perfect square trinomial, which would be a binomial squared. And we square x to get x squared, and we square 4 to get 16. 4 times x gives us 4x, and when you double it, you do get 8x. So there it is. And then we're supposed to say, now I better be using that cool square root stuff that we've been learning about. So I'm going to take the square root of both sides and have x plus 4 equals plus or minus. And then I remember it's okay to split this. So I try to reduce it first, 16/9. That's not going to reduce. But then I'll split it into the square root of 16 over the square root of 9, which is 4/3. And then all I need to do is subtract 4 from both sides. So x will equal negative 4 plus or minus 4/3. So now I could punch that into the calculator and get my 2 answers, or I could remember, hey, you're supposed to have common denominators when you put this stuff together. So negative 4 over 1, I'd need that to have a 3 on the top and the bottom, so that would be negative 12 over 3 plus or minus 4/3. So negative 12 plus 4/3, that would give us negative 8/3. And negative 12/3 minus 4/3 would be negative 16/3. That's a good one. We've got a little fraction action going on there. So 18 and 20, that was your list. Is there anything else anybody thought of? Well, make sure your name's on whatever you have that's done for me, and you can pass it. We are continuing on with section 4.6, which is about completing the square. And yesterday what we did was bits and pieces of what we have to do for the process of completing the square. Today we want to put it all together and say, well, if I can do all of this little stuff, what do I have to do in the end to get this all together? And we were, where? 4.6 day 2 was marked. Here it is. Come on, smartboard, behave. Let's see if I can squish this up a little bit. It got a little large. It's not going to let me squish. Too much stuff going on, so hopefully it'll behave. All right, we'll just give it a try. So 4.6 day 2 tries to explain what it is we've been doing and how we can put all of this together. So it says, how can we use pieces like these three to form a square with side length x plus 3 and no overlapping pieces? And it says, show a sketch of your solution and how many of each piece do you need, and explain. Now, I wanted to show you that. We're not necessarily going to take the time to go through and make all of that happen, because what we see, and I think it's down here, yep, is how this process of completing the square comes together. There is a visual that goes with this, because completing the square is really completing a square. If we put the algebra together, we would get something that looked like this. And if we have to complete the square, we have to figure out what do we put in this little spot right here to fill this up. And we learned yesterday there's a formula for that. That's b over 2 squared. So if x squared plus bx is not part of a perfect square trinomial, you could use that coefficient of b to figure out a constant c so that we would make it be a perfect square trinomial. When you do this, you are completing the square. And I'll go through this visual again so everybody can see that. But the name of the process is based on the visual of the fact that we are finishing up a square. Everybody remember what a square has to have from geometry? 4 90-degree angles and 4 congruent sides to be a square. So taking a look at this picture, here's what they're saying. If we had that big block up there and we wanted to put a B on it to try to get it to be a square, we'd say, well, that's not working. That's a rectangle. So how do I get it to be a square? Well, the first thing we might try is to cut this and move it up here. And that's what we see in this second drawing. And we'd realize we're still missing a piece. We don't have it all. So how do we get that little piece? Well, over here we had B. And we decided to cut that in half so we could split it in these two places. That made it B divided by 2. And this little spot right here would be dimensions B over 2 by B over 2. And that's how we get that B over 2 squared piece. Because B over 2 times B over 2 is B over 2 squared. This sometimes helps people kind of put the math together as, what are we doing when we're completing the square? You know, all this algebra stuff, what is this for? And why would we want to have a square in the first place? Because squares are so easy to work with. You know, they really are. You know you've got those 4 90-degree angles. You know all the sides are the same. And so completing the square is a helpful process when we're trying to find, well, things like a deck, you know. putting a deck on your house, stuff like that. It makes the math so much easier. So when we're doing this completing the square process, there is a visual that goes with it. So this says rewrite that equation x squared plus bx equals c. Give you a little example here for this first one that they have up here. They're talking about a problem where we have x squared plus 6x plus 7, and they ask us to complete the square. And we would say, that's a 7. That's not a perfect square. I can't do that with a 7 there. So we move it out of the way. That's what we do. That would be our first step. If that last number is not a perfect square, get it out of the way. Put it on the other side so you can find a number that will make it a perfect square. So that's why when you look at this, it doesn't look right. You know, we've got x squared plus bx equals c because they moved that non-helpful number over there, that number that was not a perfect square. And then it says to do this, get all the terms with the variable on one side. Yep, stuff with the variable is over here. And put the constant on the other side because it's not a perfect square. And then divide all of everything that you have, every term, by the coefficient of x squared if it's not equal to 1. So we've just listened to the one glitch with completing the square. Completing the square will solve any quadratic. However, you have to make sure that your x squared is a 1, or it doesn't work. So we move the constant, the number, out of the way, and then we make sure that our x squared is a 1x squared. If it's not, we have to divide by whatever's in front of there to get rid of it. Then we start our process of figuring out what is b over 2 squared. We need that perfect square because we have to make this a perfect square trinomial. In my example, 7 wasn't a perfect square. I moved it out of the way because it wasn't a perfect square. So my next step would be figuring out, well, what perfect square would do this? And in this case, here's my b, so I'd do 6 over 2 squared. Well, 6 over 2 is 3. And 3 squared is 9. So that's the next step. After we move the number over and make sure there's a 1 in front of the x squared, we do b over 2 squared. We just made a perfect square trinomial. So we can factor it. I've got negative 7 plus 9 on the other side, and that's just a little 2. How does x squared plus 6x plus 9 factor? Tell your chicken wing elbow partner, what does that look like in those parentheses? Exactly, x plus 3. Because we square an x to get x squared, and we square 3 to get a 9, and it works because 3 times x doubled is 6x, so it works. So that's the next step, they said. Well, that's not going to be hard. We'll get that with no time. Now, I don't have x by itself yet, but yesterday we learned how to do that. Find the square root. We just made a perfect square. The reason we did that, we wanted to take the square root to make this problem easier. So we're going to take the square root of both sides and get x plus 3 equals plus or minus the square root of 2. And I had a couple of people bring this up during the homework. So remember, whenever you physically write a square root, you have to put plus or minus down because, well, it works. I mean, if you're asking for x squared equals 4, it could be positive 2, it could be negative 2. Both of those numbers will work. And then we're almost done. Last step says solve for x. Super close to done. All we'd have to do is subtract 3 from both sides. And we know that we can't put integers and radicals together, but we can certainly write this as negative 3 plus or minus the square root of 2, so we have everything over on one side. So every step of this we've done. We just haven't put it all together yet, like we just did in that problem. So that's today. Today will be, let's put it all together. Let's make sure it happens. Alrighty, here's the first one. Solve by completing the square. X squared plus 8x minus 15 equals 0. Maybe we got lucky. Maybe this is already a perfect square trinomial. Is it? No, negative 15 isn't. So let's move it out of the way. Let's get it over on the other side. All right, so 15 was not a perfect square. Second thing to check is there a 1 in front of the x squared? There is, so we don't have to do any funky dividing with this one. It's fine. And then I have to figure out what is that magic number that's going to make that a perfect square trinomial. And notice how I put boxes on both sides, because this is still algebra. So what we do to one side, we have to do to the other. We don't have a choice. So let's see. What's b in this one? 8. ax squared plus bx. And our little formula is b over 2 squared. So it'll be 8 over 2 squared. What's 8 divided by 2, everybody? 4. So we'll get 4 squared. And what is that? 16. So we need to add 16 to both sides. Well, that makes the right side the easiest one to do first. So we'll just go ahead and say 15 plus 16 is 31. Just get that out of the way. But we also know what the left side is going to be, because we know that x times x would give us x squared, and we just said what we had to square to get 16. That was 4. So in this math over here, we already have what we squared, the 4. And I don't have to check the middle term, because I used the middle term to make this happen. All right, super duper close, right? Doesn't look like an answer yet, though. So what would we do? Square root both sides. Good. X plus 4. Yep, don't forget your plus or minus. Exactly. And then stop for a second and ask yourself, can I simplify the square root of 31? 25 doesn't go into it. 16, 9, 4. Can't do it. That's okay, but we're not quite done. What else? Subtract the 4. So x equals negative 4 plus or minus the square root of 31. Now notice that's actually two answers, because it's negative 4 plus the square root of 31 and negative 4 minus the square root of 31. And I'm going to tell you, I would love you to just leave your answer like that, in simplest form. You might find that in the book they gave you decimal answers, and that's because sometimes it's easier for them to just type in a decimal than it is to type in these answers that have exact answers. So you could always check it by plopping it into a calculator and then check it with the answer they have in the back of the book. But really, I only want you to keep going and do that if the problem says round to 2 decimal places, or something like that. Otherwise, we're going to leave these exact as they are. Alrighty, let's try this one with a little bit less of me and a little bit more of you. And since I'm hearing the same voices today, I'm going to go ahead and call on people for this one. So think about what your first step would be. If you want to, feel free to ask your chicken wing elbow partner. Jillian Telfer, you looked like you were cranking on this right away. What was your first step? Perfect. Add a 21. Okay, big hint there. Look at what I did. My box is up there. So the next thing I would want to know is, what should go in the box? Check in with your chicken wing elbow partner. Make sure you're doing it right. You ready for me? Okay, Kaylee, you're looking ready. Yeah, it's 4. Negative 4 divided by 2 squared would be negative 2 squared, which is 4. Good job. So now the right side is nice, is 25. And on the left, we have to write that as a binomial squared, so we'll be able to take the square root. So go ahead and figure out what you should put in those parentheses. Check in with your chicken wing elbow partner if you need to. Maddie, way in the back there, you're looking kind of done. What'd you have in here? Perfect. X minus 2. Yeah, perfect. Because you think, what did I square over here to get that 4? Oh, it was negative 2. All right, we're closing in on it. I need to know the next step. Michaela, you're looking done now too. What'd you do next? You do, absolutely. So x minus 2 equals plus or minus 5. This time we're going to be able to get the answers because this didn't come up with some goofy square root. Alrighty, so we're still not done getting x by itself. Colton, what should I do? Exactly. So I'm going to get two answers. 2 plus 5, which is 7, and 2 minus 5, which is negative 3. There it is. Done. Now, that does tell me something interesting. This one up here, we got a really goofy answer. Negative 4 plus the square root of 31, negative 4 minus the square root of 31. That's not factorable because I didn't get nice answers. So I had to have a different method to solve that one because it wasn't factorable. This one came out with two really nice answers, two integer answers, 7 and negative 3. That means we could check this one by factoring. Do you know two numbers that multiply to negative 21 and add to negative 4? Negative 7 and positive 3. So we are right. We got them. We got them. So when it works out nice, that means there was another way this one could have been done. It could have been factored. All right. You're doing a good job. Now let's do one a little harder, a little bit. What is the solution of 3x squared minus 12x plus 6 equals 0? Is 6 a perfect square? So we'd have to move it out of the way. And actually, I would flip these two steps they have right here. Because it makes it easier. And easy is always better. Simon. We could also do that. Exactly. Because Simon's bringing us to the next step, and the next step is you have to have a 1 in front of the x squared. If it's not there, you have to divide by whatever's in front of the x squared to get rid of it. So we're going to have to get rid of this 3. And that means everything has to be divided by 3. So we would get x squared minus 4x equals negative 2. Well, now it looks like the stuff we were just doing before. That's no biggie. Find the number for the box, please. You guys are already doing like the next 2 and 3 steps, aren't you? Everybody's got their head down and they're going to town on this. All right, what number did you put in the box? 4. So we would have our x squared minus 4x plus 4 equals 2. And yeah, I know you're already factoring and everything. What did you put in the parentheses when you factored? X minus 2, right. Take the square roots. So x minus 2 equals plus or minus the square root of 2. Is there anything we can do with that? Any way to simplify the square root of 2? We got nothing, right? I mean, 4 is our first perfect square. That's not going to divide evenly into 2. So we just leave it, except we're not quite done. Last step. Add the 2 to move it over. 2 plus or minus the square root of 2, and we know we can't put those together. One's an integer and one's a radical. That is a perfect answer right there. 2 plus the square root of 2 and 2 minus the square root of 2. So it's really a perfect 2 answers that we have there. And that means this one was not factorable. We would have had to find some other way to solve it. So completing the square is an excellent way to do that. So as I said, we're going to learn the quadratic formula over the next 2 days. And you're going to memorize the quadratic formula, but we have no idea why it works. Every step that we just did in this follows math that we already know how to do. So it makes sense. So completing the square just makes sense when you can't factor a quadratic. Alrighty, that looks obnoxious. Whew. I can think of lots of things wrong with that. What do you see that's wrong? Two x squared, we're going to have to deal with that. We're going to have to get rid of the 2. What else do you see that's goofy? Yeah, they're not even over on the same side yet. And it's always a good idea to start there, just in case things just fall into a perfect situation. So we'll subtract an x, if I can write that, and subtract a 9. What are you thinking? Because there are several ways we could get this one a little easier. Factor the 2 out now? Sounds like a good plan. So now I have to ask myself, does that 2 matter for my answers? Is that 2 attached to our x's anymore? Then it doesn't matter. So I don't even need it anymore to find the solutions. I can just keep going with that. If it doesn't have an x attached to it, it's not part of the solution. All right, that does not look good. Is that a perfect square trinomial? Rats. So what should we do? Add the 3. Get it on the other side. It's not good. We don't want it there. X squared minus x equals 3. Gonna need to fill the box. This takes away a little bit of our happiness, just a little bit. Because b is not even, and when b is not even, you get fractions. But it's okay, we can deal with it. So what is b? No, b. -1. ax squared plus bx. So we're going to need -1 over 2 squared. That's not a big deal. We talked about this yesterday. As long as this is pure multiplication or division, we can just distribute that 2. So it'll be -1 squared over 2 squared. That's 1/4. That's not a horrible fraction. Not bad at all. So I'm going to have to do a little plus 1/4 here. All right. Well, I got a problem over there on the right-hand side. And I could use a calculator for it. I could do 3 plus 1/4, enter, math number 1, and get the number back. Or I could just do common denominators and change 3 over 1 into fourths. And that would be 12/4. So 12/4 plus 1/4 would give me 13/4. Again, just, you know what, I'm going to show you this. Because I know some of you are looking at that going, Cedar Home, I'm never going to do that on my own. Well, then just do this. 3 plus, parentheses, 1 divided by 4, parentheses, math number 1. No brain power involved. You just punch it in and get it. It's cool. You know, don't think that that's the step that's going to stop you from being able to do this. It's not. All right. Well, here's where it's really helpful that we write down our work for that box filling number, because we might forget what it was we squared to get 1/4. It's right here. -1/2. That's what we squared. That way we don't have to think through all those steps again. I think we know what to do with this now. What would we do next? How do you solve it from there? Square root. So x minus 1/2 will equal plus or minus. I can't reduce 13/4, but I could split it and see if anything good happens. Does anything good happen? Square root of 4 is 2, and that's excellent because that was on the bottom. And remember, we can't leave radicals in the bottom. So I'm not too worried about the square root of 13 on the top. If that had been on the bottom, then I'd have to rationalize the denominator, but it wasn't. Oh, we're so close. What's left? Add 1/2. Can we actually put those together? No, just got to write them. 1/2 plus or minus the square root of 13 over 2. Because they're both halves, but again, one's a radical. So we can't put a radical together with an integer. Just have to say, good enough, done. All right, so that was kind of tough, huh? A little bit more going on with the fraction there. Before Thanksgiving, we graphed these. You did a really good job of graphing these before Thanksgiving. Ideas. Find the vertex. Ooh, that'll be good with this one because this is in vertex form. So where is the vertex? So what numbers would it be in this one? -2 and 1. All right, so our vertex is at -2, 1. Something else important is always going through that vertex. What's that important thing? Axis of symmetry. Good. I heard a couple of people say it. Is there some easy point that we could find on this that would make it go faster? People always forget this. Anybody remember the super easy point you can get in vertex form? Yeah, put a 0 in. You know, that's always the easiest one to get. Might be enough. Put it in. 0 plus 2 is 2. 2 squared is 4. 3 times 4 is 12. 12 plus 1 is 13. Rats, we're already off our grid, aren't we? So what would be another good number to try? Yeah, I'd go with -1. This one is going up so fast because of that 3. So put a -1 in. -1 plus 2 is 1. 1 squared is 1. 3 times 1 is 3. 3 plus 1 is 4. That's better. A little skinny thing here. And we've got it. So that was vertex form before the break, before we had a week of sleeping in. So now, notice how that went faster than yesterday's? We didn't have to do the x equals -b over 2a and all that stuff. So wouldn't it be cool that if they're in standard form, we put them into vertex form and make it super easy to graph? We know how to do that. It's completing the square. That's how we do it. Because take a look at this formula right here. This is exactly what we've been doing. We've been making those nice little perfect square trinomials. So let's make this one into vertex form. Let's see. Y equals x squared plus 4x minus 6. Now it's got a y over there instead of a number, but that's okay. We'll just do our math with it. Is -6 a perfect square? Well, then let's move it over to the other side. We don't want that in there. It's in the way. But don't forget about the y. That's a big part of the math. All right, so here's what I need. I need this to be a perfect square, which means I have to find the number to fill in the box. And what I do to one side, I have to do to the other. So find the number to fill the box and check in with your chicken wing elbow partner and make sure they've got the same number. Been sitting in these seats for 2 days. Some of you still haven't talked to your chicken wing elbow partner. Talk to them. You getting a 4? Okay, so we've got a 4 here. 4 divided by 2 squared is 2 squared, which is 4. Well, this isn't going to be too hard. I mean, so what if there's a y over here? It's going to be y plus 10. We can do that addition. That's not a big deal. And over here, we now have a perfect square trinomial that we can factor. So figure out what needs to go in those parentheses. Do you have it? What goes in there? X plus 2, right, that's what we had to square over here. Now normally at this point we'd say take the square root, but we're not doing that this time. We don't want this to have some kind of goofy square root. We want it to look like this. So I've got the nice little squared thing done. The only other thing I have to do is get this y all by itself, and I'll have this totally finished. So how do I get y by itself? Subtract 10. And this is the part where people always go, should we subtract the 10 from the 2 in the parentheses? Well, if one's in parentheses and one's not, the answer is no. You can't do that because the order of operations says parentheses have to go first. So we're just going to have to leave this, the quantity x plus 2 squared minus 10. But that's not bad news, because that fits super close to our vertex form. That's good news. So now, we did all of that, so it would be very easy to tell them what the vertex is. So find the vertex and tell your chicken wing elbow partner what you got. Everybody have it? What is it? -2, -10. Good. This is the one with the x that's always the opposite. And then they said find the y-intercept. That's because that's supposed to be the easy point to find. Because to find the y-intercept, you make x equal to 0. And you plug it in. So go ahead and do that. Check in with your partner. Make sure you're getting the same numbers. Check in with them. I want to hear everybody telling their y-intercept to their partner, so nobody's left in the dust. -8, right? No. What is it? Well, that wasn't hard. But the x squared was a 1 again. You know, the 1 in front of there, that makes that easier. So I'm going to have you guys help me out more with this one. Y equals x squared plus 3x minus 6. You want it in vertex form. What's your first step? Add the 6. What's the next step? B over 2 squared. This one's going to be a little tougher. Going to have a little fraction action. We've got a 3 here. I heard somebody say it, though. 9/4. Yeah, 9/4. Okay, but now what? We got this y over here, and we've got 6 plus 9/4. Again, your calculator will do 6 plus 9/4 if you don't want to do it by hand. But you can change 6 over 1 into fourths by multiplying the top and the bottom by 4 and getting 24/4. And then do 24/4 plus 9/4 is 33/4. It's not that big a deal. So use your calculator or don't, but you should get the 33/4. Now this is going to look a little tougher, isn't it? There's our x. What did we square to get 9/4? 3/2. All right, so right now, because everything's kind of running together here, this looks like this. It's almost done, isn't it? What do we have to do to get that in vertex form? Get the y alone. Subtract the 33/4 from both sides. And no, it has absolutely nothing to do with what's inside the parentheses. Now, what do we go to all that trouble for? We're supposed to tell them the vertex and the y-intercept. Find the vertex. Tell your chicken wing elbow partner what it is. Everybody have it? Not a very pretty vertex, is it? It's okay. It's not like we have to graph it or anything. They just said find it. And then this part, yeah, you might want to grab your calculator for, because this one's going to have fractions, remember. I don't know. Maybe you'll be okay. Put your 0 in for x. Zero plus 3/2 squared will be 9/4 minus 33/4. 9 minus 33. Yeah, too many people are looking like deer in headlights at this point, so I'm going to go ahead and punch this in so you can see it. Yep, negative 24. Hey, we can divide negative 24 by 4. We can. We can. Again, you could do all that fraction stuff with your calculator. You wouldn't have to do any of that thinking, so don't worry that the fractions are going to slow you down so much you're going to give up. You guys were doing great. I want you to look at this. From start to finish, look at all the math you just did. You see that? That is impressive. You should be proud of yourselves. That was really good. So, yesterday was the 3 kind of individual steps that we have to do to solve these. And today we put them together into these monster problems. That's really cool. Really cool. I suppose I should turn this off.